Flack math! Give me some math and I'll give you some flack. Flack math!
All right, lesson 13. Yes, it does have a name. Thank you for asking. This is our introduction to triangles. So triangle literally means three angles. Intro to triangles. All right, so there's three ways to classify a triangle by its angles. What are the three ways?
A right triangle.
And what's the definition of a right triangle?
I don't remember.
90-degree angle triangle.
Okay, so what do you mean by that?
It's a triangle.
A right angle is a 90-degree angle. What does it mean to be a 90-degree triangle?
Isn't it that it has at least one 90-degree
Yep.
angle?
Well, it can only have one. Triangle with one right angle in it. Okay? What's the other kind of triangles? Do you remember? Classified by their angles.
Isn't it like
Do you remember? What, Tori?
Quadrilateral triangle.
So quadrilateral is just four sides. That's a cool name for a band now. Quadrilateral triangles. Right? Maybe not. Okay, an obtuse triangle.
oh, I know, cute.
Yeah, so this is a triangle with one, because you can't have more than one obtuse angle, right? Think about it, trying to draw a triangle with two obtuse angles, boom, 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 those sides wouldn't connect. With one obtuse angle, what about an acute triangle? How do you define that?
Probably has a two thing.
Yep, but every single triangle in the universe has at least two acute angles in it.
They all have all angles.
Yeah, so triangle with three acute angles. So you can't say with one acute angle in it, because every single triangle, you can try to draw a triangle with less than two acute angles in it, but it's impossible. Okay? So here's like a right triangle. Just has to have a right angle in it, but see that the other two are acute. You can prove that mathematically, because if this is 90, remember they all three have to add up to 180. So if this is 90, these two have to add up to 90. So if they have to add up to 90, then they're less than 90. Okay? Obtuse, well, that's more than 90. So these two have to add up to less than 90. So if the sum is less than 90, that means the individual angles have to be less than 90. But in an acute triangle, that's the only way you can have three acute angles if it's an acute triangle. Okay? Questions on that? So you're going to have homework. They're going to ask you to classify these, and most of it, you're just going to look at it and you're going to try to determine if it's acute, right, or obtuse. If it's right, you're going to know right away. What are you going to see in a right triangle always? A little square thingy, okay? So if you don't see that, you cannot assume that it's a right triangle, even though it looks like it. You can't assume that it is, all right? So your answer might be, I don't know. There's no, I mean, I guess you could measure the angles with a protractor, figure it out. Okay?
When do we have to do test corrections by?
As soon as you can, before the next test. Probably the best way to do it. Next test will be a couple Tuesdays from now is when it'll be due.
2 weeks or 3?
Yeah, so this week is just problem sets again. And then next week we'll do a lesson day on Tuesday and then a test review on Thursday.
Oh, sick. Okay.
Okay? So far, so good? You guys getting this?
Midnight? Yeah. Yes. We're wonderful at it.
So you might be asked to define one of these classifications. Remember, the only tricky one is the acute triangle. So you can't say it's a triangle with an acute angle in it. You can say this for a right triangle is a triangle with a right angle in it. An obtuse triangle is a triangle with an obtuse angle in it. An acute triangle is not a triangle with an acute angle in it, because every triangle has an acute angle. It's kind of like saying spell pots 5 times. Did we do this already? Spell pots 5 times as fast as you can. Okay, what do you do at a green light?
Go.
Let's go.
I'm a driver.
I said go.
All right, I know, because you probably heard it before. Or something like it. Okay, so now you can also classify an angle by, or classify a triangle by its sides. Okay, so these are angle classifications in a triangle. So classifying a triangle by its angles. Now these are side classifications. Well, what do I mean by that? Can you think of an example? If I say, well, it's this kind of triangle based on its side lengths.
Yeah, because it's like 3, 5, 4 triangle.
Oh yeah, but that's still that's like a Pythagorean triplet. So that's a different way to do it. Yeah.
But
that's
it's still a side classification, isn't
But
it?
and that, well, that's yeah. Well, but that's not what I was looking. You'll understand once I tell you. But I'm wondering if you guys know what I'm going to say. Okay. All right. You don't have to. All right. What is a triangle where all 3 of its sides are the same length? What is that called?
Equilateral.
Right, equilateral triangle. So, all 3 sides are the same length. Okay, what's the other one called? There's 2 other ones. So there's 3 classifications with angles, there's 3 classifications with sides. Well, let's go down one. What's 2 sides are the same? What does this one look like? Or what is this one called? It's been a while. It's been too long.
When did we learn this?
I feel like this side feels a little isolated from the other 2, like twins.
Isosceles.
Isosceles. Jilly, I love how you looked up really quick because you knew what it was. You were so excited. So this is technically at least 2 sides the same. Now, so an equilateral triangle is technically an isosceles triangle, because an isosceles triangle, the only conditions of an isosceles triangle, it has 2 sides the same length. At least 2 sides. Well, these 2 sides are the same length. So it's an isosceles triangle. It just also happens to be an equilateral triangle. Okay? And what's the ugly one? The one with no sides are the same.
Ugly duckling?
Yeah.
It's like that's right triangle.
I know, but if you just look at the sides, no sides are the same.
That's a right triangle.
Do you guys like
Awkward
reptiles?
triangle.
Reptiles are ugly, in my
They're
opinion.
hideous. They're
Yeah.
ratchet.
What do they have all over their
Yeah,
body?
scales.
Scales. Jilly?
Go oscillate.
Scalene. That's right. So these are scalene triangles.
I tried. I was trying to hope for the best, I guess.
No sides are the same length. Okay, do you guys remember that I can't say the same, no sides are the same. I have to say no sides are the same length. Because remember, only numbers can be the same or equal. But if I'm talking about shapes, I have to say their dimensions are the same. So it's kind of one of those grammatical things. Because if two triangles look the same, they're not equal, they're congruent. Yes.
Did you say the lengths are equal?
Yeah, because lengths are numbers, right?
Oh, yeah. Well,
So
theoretically.
sides are not numbers, but lengths are numbers. Okay? All right. So you can look at example 2 if you want to. In the diagram, which triangle is scalene? So you just have to figure out which ones are scalene by looking at the diagrams. Which triangle is equilateral? Are any of the triangles isosceles but not equilateral? Okay? So when it's asked for isosceles triangles in a list of triangles, you have to pick out all the ones with 2 sides the same length and the ones with 3 sides the same length, because those are technically isosceles triangle too, right? But if it asks for isosceles triangles that are not equilateral, then you just pick the triangles that have 2 sides of the same length but not the third, okay? Got it? All right. So, the vertex of a triangle is one of the points where 2 sides of the triangle intersect. A lot of this is review, but we'll write it out. So every triangle has how many vertices?
3.
3. Just like it has 3 sides, but it kind of makes sense because triangle means there's 3 angles, which means there's 3 vertices, okay? So if I'm looking at this triangle, A, B, C, has 3 vertices, and this is just plural of vertex. A, comma, B, comma, C. And then it has this guy. So this is the perpendicular distance from the base of a triangle, which can be any of the 3 sides. You just have to decide which one it is. The perpendicular distance from that base to the opposite vertex. Okay? And it happens to be the shortest distance from the base to that opposite vertex. So that's called the height. Sometimes people call it the altitude, but most of the time it's called the height. So you could rotate this and pick a new base and a new height, but when you're remember when you're calculating the area, it's 1/2 base times height. It doesn't matter. You'll have different numbers for each side and different heights for those sides, but you should get the same area no matter what base or height you choose. Okay? So see how the height is always relative to what base you choose. And the base is always relative to what height you choose. Okay? So sometimes that height is a little bit trickier to find, like in an obtuse triangle. That height, remember, is the perpendicular distance from the base to the opposite vertex. Well, the opposite vertex is not above it, so you just have to extend it a little bit and then draw your height. So this is the height of that. It's still the perpendicular distance. So if this was the ground, this is what your altimeter would read. That's how high it is in the air, okay? So that ground can extend in order to determine the height. So this is still the base. The base is not the extension of the base, it's still just that distance. Okay, area of a triangle, area equals 1/2 base times height. Or you can multiply the base times height and cut it in half, divide it by 2. So this is all review. The easiest way, what I always tell my pre-algebra and math 7 students is this is one of the most common mistakes in finding the area of a triangle is what does everyone forget to do?
Divide by 2.
Divide by 2. Okay, so if I were to draw a triangle here, here's my base, here's my height. Well, the area of that whole rectangle is base times height, right? But we don't want the whole rectangle, we only want half of it. So that's why it's half of base times height, or base times height, cut it in half, divided by 2. Okay? So you need to remember that. Shouldn't be too difficult since you've been doing that for 3 or 4 years at least. Okay, there's a little proof that goes through that, but we're not going to do that. So finding the perimeter and area of a triangle. So sometimes it'll be tricky, and it'll give you something like this. It'll say 12.5, 31.5. Here's 40.26, and then it'll give you 10 centimeters here. So sometimes it'll say, find the area of this triangle, and what would a typical pre-algebra student do?
Don't divide by 2.
Not divide by 2, but what else might they do? Kate?
Oh, it's just, I wasn't gonna say anything, but I'd be stupid.
Be stupid? Yes. What? How can they be stupid in this?
3.5, 34.5
31.5.
times the, what is that, 12.5
Yeah,
divided
so they
by
would,
2.
yeah, they would do this base and this, what they thought was a height, okay? So that's a classic mistake, but remember, it's base times height. So 31.5 times 10, what's that? Good, 315. Divided by 2, well, you can cut that in half, right? 157.5 or something, okay? So, be careful of that. But they might give you that either to throw you off, or they might ask for the perimeter as well. Well, you can find the perimeter, just add up all the sides. All right? Do we need to spend much more time on this? Okay, there is a farming application. If you want to look at that, you're welcome to. But we're not going to as a class. I used to live in Iowa though, so if I was still in Iowa, I might go through that because little Jeb might need to know that solution, okay? But we're not doing
There's
it.
farms up in like